Hello and welcome back to my job tutorial series. You can see our products from the previous episode, which of course was basic generics, and now we're going to go into advanced generics, included but not limited to generic methods, as well as wildcards, and wildcards are fun. At the end of last episode, I believe we addressed the problems of extension and inheritance among generics and actual numbers and stuff, and we're going to address a solution in this episode. So sit tight and prepare to learn. Now, before we get into wildcards, we're going to do generic methods, which are pretty easy, but important nonetheless. Of course, we got to set up our main method first with our string array. And then I'm just going to make a quick class or two. We're going to call this one pair. It's just going to be, a pair. Of course, it's going to be a generic class as well. We're just going to, private k key, private v value. Of course, you should all know this stuff, I hope, by now. And okay, key v value, that should work. Do a public void set key k key, this dot key equals key. Just a quick simple get sets. V value. And these are definitely not, these are going to be the get. So this is going to return type K, this is going to return type V. So we're just going to do this dot value equals value. Then this one will just return this dot key. And the normal boring stuff. Well, maybe boring. It always depends on your scope. But here we have a simple generic thing. I guess we'll start with that. Now let's just make a thing, and we'll, yeah, well, we can do that. So let's just do public static pair, and it'll just be a string integer pair1 equals new pair, diamond notation, because it can infer what the heck that is. And let's just give it a thing of pair number 1. And we're just going to copy this and call it pair 2, pair number 2, value of 10. Why not? And we're just going to make a nice, simple public static. Then we have to put a little thing here. You'll learn what that is soon. Boolean compare. And what it is, it's going to accept parameters of a pair with type V and type K. Pair 1. P1. It's going to accept another pair of type V and type K as well. It's going to be P2. Okay, it's having an error because we have to return a boolean just so we're just going to return false for now. So now it's alright. So this right here, this generic type, makes this method a generic method. Basically, you're creating your own generic types that are only accessible in this method. So for instance, if we took this out, we would get an error saying, hey, what the hell are V and K? We should make a class or an enum called K, because there is no K or V. So in order to make these new types, we have to do vk. So now within this method, now they have new type. The new generic types are objects, which are v and k. So what we're going to do, we're going to compare these pairs and see if they're equal to each other. So if p1 dot I don't think you can do equals. Maybe that certainly would make it easy. Return true, and then else it'll return false. But that's just to make it simple. We'll just do else, so it's obvious. So now let's just I have no idea if this is gonna work. If it works, then hoorah! Let's just try this real quick. Oh wait, I should probably system.out.println. Oh wait, no, this should be in main. What did that? I'm sorry. I don't know what I'm doing. Just say bool1 equals compare pair 1, pair 2. Boolean 1. And we're going to print out Boolean. Okay, yeah, so we can't do that. I mean, this is too easy, I mean to say. So if p1 dot get key equals p2 dot, actually we should just do dot equals just in case, because like you can't do equals on some objects, you can only do that on like integers and stuff. If it equals p2 dot get key and double ampersand p1 dot get value dot equals p2 dot not get value. So now it should return true. True. And if we change this to, this is now pair number 2, it'll return false, because these pairs are not identical to each other. So now, that'll teach you generic method. Now we get into the fun part, or at least what I like to call the fun part, which is wildcards. Wildcards, they use question marks. This question mark, well, you don't exactly use it in that context. Let's go back to pair. Let's make it a number pair. How about a generic point? Because there already is a point class which just stores an x and y coordinate, but this point class is going to be a generic, so it's going to be x and y. But let's say, since it's going to be holding a coordinate, since it's going to be holding a coordinate, we don't exactly, a string won't work as a coordinate. Like, it's a x coordinate hello and y coordinate world. No, it has to be a number. So we're just going to set up those real quick because I was explaining, and we're going to do question mark. Well, no, we don't have to do question mark. We can do x extends number. We can do y extends number. So that means when you pass arguments and you're creating a new generic point object, that means x has to extend number and y has to extend number. So we just make, a public generic point x x y y, because well, this dot x coord equals x, this dot y coord equals y, and that's apparent. And then what else you would do is, oh yeah, you can do the gets and sets, but instead of doing that, I'm just gonna do public. I don't feel like doing get and set right now, unfortunately. But yeah, now we can make a public, what the hell is my spelling doing? Public static generic point, like if we, let's just put integer, and float. Gen point 1, and we'll just see that. See, this works perfectly. Integer extends number, and float extends number. But if we try to do something out of line and put string, we get an error because string does not extend number, and we're saying, hey, it has to extend number. So we're just going to put this down back to float equals new generic point, diamond notation because we're lazy, and we're just going to give it 5 and 3.14f. And that should work perfectly fine. Let's just do a system.out.println gen point 1 dot y coord. So yeah, that's extends. It points out 3.14. Okay. So another thing we can do is we'll just create another class because we just love creating all these classes. Actually, we're gonna do something else. We're gonna create something else, and I think I just want to make something in here. We'll just do something in here. We'll do a public static class super pair. And no, this isn't. And no, this pair is not super or extraordinary, but it will come in handy. It just means that it's going to be super. So what we're going to do here is k super number and v super number. What do you want? What? What do you want this time? I think they're confused. I certainly am not. Maybe you can only do those with wildcards. Though I do see why. We'll get back to this. Instead, I'm going to show you if this probably works with wildcards. So now we're going to get into other things. I showed you can use the extends, and there's also a super, and there's also a blank, but now we're going to get into wildcards. Those are just binding the generics. Like this is an upper bound, which means you're bounding it to this has to extend number. It can't go any higher in inheritance. And I was trying to show you super, but that's the opposite. It can't go any lower. So if we did super number, that means you can't use integer or float or double or any of those. You can use only number and things that are above number. And the thing that's above number is object. So you can pretty much only use number and object for that. But I think you can use it in a method to accept stuff. And oh yeah, now this is also how we get into the other thing. Let's just do a public static what should it return? String. And we'll call it I don't know why I'm pulling a blank. A wild string. And what it's going to do, it's going to accept a pair, and it's going to accept a pair that has a string and anything that supers number. And we're just gonna call that P1. It doesn't really. Oh yeah, we have to. Let's just return null for now, so we don't get that error, and you can see what I'm doing. So basically, it accepts a pair that the key has to be a string, and the second thing has to be anything higher than, greater than or equal to number, basically, which only doesn't really make actually pair. Yeah, that makes sense perfectly. Okay, it does make sense, but that isn't the point we're trying to get out. Well, this isn't the method to do. Let's see. So, yeah, that's when you use the question mark. So that means as long as the second thing is above number, so it's an object or a number, then it'll work perfectly. That doesn't, but we can't, like, instantiate number. We can instantiate Well, fine. We'll make another one of these, and we'll call it pair 3. And number 3, this is just going to be a normal object. And the normal object is just going to be a new object. And we'll call it pair number 3, of course. And return p1.getKey. So basically, if we just call string 1 equals wild string pair 3, it works. Because while I showed you in the previous episode that well, I'll explain that more. But basically, this will get this string, and since it has a number or an object, as an object, which is higher than number, and we're using super, so that should work. It'll print out. Oh, wait, what? Oh, I forgot. We had to print out string 1. There, we got pair number 3, because it worked. If it didn't work, we wouldn't be getting this. So basically, since its second one is greater than or equal to that, it works. If we tried to do pair 2, where the second one is integer, we'd get an error. Because wild string super number in the main type is not applicable for the argument's integer, since integer extends numbers, and it's saying you need parents of number, not children. But to make this a little make sense more, we can do extends. As long as the second argument extends, and now this will work, and if we did pair 3, it wouldn't work, since object does not extend number, but integer does extend number. We can also pass number into it as an argument, but the number class, you can't instantiate it, so it's not very useful, unfortunately. But yeah, you can do that. Another thing you could do, I mean, super is a lower bound, and extends is an upper bound when you're dealing with wildcards. And basically, what you can also do is just a question mark. Just one wildcard, which means it can be anything. Anything at all. And basically, with your pair, if you get it, it can be anything. And basically, the only time you would want to use an unbounded wildcard if you're just using it for objects. If you get value, it'll return a wildcard, which it's very inconvenient, because then you'll have to make yourself deal with getting wildcards returned, which isn't fun, and it's kind of hard to deal with. Like if we go to value, it'll return an object, since basic wildcard, it just returns an object. So you only really want to use it when you're just dealing with the object of it. Yeah, I cannot convert from caption number 1 of question mark to string. Oh yeah, because I get what it's saying. I'm trying to return something that isn't a string. That's not the problem. But yeah, basically you only want to use this if you're doing the bare objects of it. When you're using methods that come with objects, such as notify, or notify all, or wait, or clone, or some other few things. But you often do not want to do that. So we'll just do question mark extends number, and I'll just leave it there for now. And we'll do get key. Leave it at that. Okay, so now this is the end of the lessons for generics. Now just a quick bit of advice. While generics are really nice, there are a couple of restrictions, such as you can use them with primitive types. That's why I've been using integer, the object that contains the primitive type of int. So if we tried int, we would get an error, because you can't do generics with primitive types. That's one of the bad things. You can't create instances of type parameters. Like you can't do public export equals new x. So yeah, that won't work at all. You can't instantiate them at all. So what else you could do is well, what else you can't do, I should say, you cannot declare static fields whose types are type parameters. So you can't do public static x, because you can't do static fields of them. Yeah, okay. And then you can't use instance of, like when I showed you the conditional instance of, you can't use like instance of x in it, unfortunately. Um, you can't create an array of this, so you can't like do an array of x's because well, for reasons like it's not serializable or some other things. Don't worry about it. You can't create um, you can create, catch, or throw objects. So you can't like make a generic thing extend exception or throwable. So you can't make an exception, make a new exception class that's a generic. And the last thing, you can't overload a method where the formal parameter types of each overload are raised to the same raw type. Don't worry about it. Really. So basically the same, if we try to make another string, wild string, we made something exact, so basically we did extends integer. This won't work since basically it's possible that they could have the same arguments and it wouldn't be able to determine. So basically whenever the compiler runs, it does this thing called type eraser. And basically it converts all generics to their basic object. It basically turns this as like to either its most upper bound or object if it isn't bound. So it'll turn this into number, it'll turn this into integer. And since both of these are bound and integer is a type of number, it won't be able to tell the difference very often, which is okay. It's not that bad of a restriction, but you get the point. So this is good. Before I just wrap up this episode, not sure how long it's getting, just want to say very close to 100 views, which I'm very proud of. I'm very happy that I am able to teach all of you how to program Java, which of course is very useful. And I think every week I'll just be doing like a weekly update thing. Okay? So, and I'll probably like do that on Saturdays, probably. So tomorrow you should expect one of those. Hopefully you'll watch it. And see you next time, and good programming to you.